Just realized, so I'm recording this, by the way, but I didn't have sound on the first two slides, so there's not going to be any sound. The actions themselves should be here, but unfortunately there wasn't sound. The microphone was on mute. So I can do this. I can do that if I want, and that's a correct answer technically. I think of this as a coefficient for k and just divide by it. That's one way to write it. Or you can multiply by 4 pi squared to bring that up, and then divide by tau squared, which will get you up to here in this answer. Okay? We will practice more of solving for variables contained in radicals. We will definitely do more of that, so you'll see more of it done. I know that this was not like the easiest type of problem, but this is the type of problem that you will end up doing throughout the year when you solve for a variable contained inside of a square root. Okay? All right. So if you look at this later and you want to relook at all the stuff that's on here, I hit the microphone now, so now you hear me talking. All right. Slide 3 or page 3. These are just trig functions. So your basic trig functions. You should know SOHCAHTOA. If you don't know what I'm referring to, you got to really brush up on your work then. Okay? You should know the acronym, SOHCAHTOA. So if I want the sine of an angle, I take the opposite over the hypotenuse. So sine of theta equals what? Sine of theta equals? Yeah, 3 over 5. Okay, opposite over hypotenuse. That's the sine of theta. That equals 3/5. The cosine of theta equals? Good. Adjacent over hypotenuse, or 4/5. And last one? Good. Opposite over adjacent. 3 over 4. That should have been guaranteed for pretty much everybody. The other stuff coming up could be a little bit tougher, but you should be able to write your trig ratios based on your geometry course. Second, or fourth, whatever number this is. Determine the length of the unknown sides in the triangle shown. So now we're not writing trig ratios, but we're trying to solve for unknown variables in the problem. So how would I do so? If I want to figure out what x is in the first diagram, what can I write? Or if I want to figure out what y is, what can I write?
The sine rule, like sine
Good.
35 over y equals sine 90 over 7.
Oh, you're doing law of sines. That works. Law of sines or law of cosines works, but it's a right triangle, so you don't use law of sines. That's too much. You could use Pythagoras if you had 2 of the 3.
Yeah.
Make it basic. You're doing way too much work for yourself. So he's talking about law of sines, where if the triangle is not a right triangle, you use law of sines or law of cosines. You're going to learn about it in your pre-calc honors course this year, actually. So because it's a right triangle, we don't need law of sines or cosines. So what would I write instead?
Cosine 35 equals x over 7.
All right, we can start with cosine. That works. So then sine of 35 would equal y over 7. Everybody see that? Sine of the angle equals opposite over hypotenuse. Cosine of the angle equals adjacent over hypotenuse. That's where that's coming from. Now, if I want to get x and y by themselves, I just multiply by 7. This becomes 7 sine 35 equals y. And this becomes 7 cosine 35 equals x. And those will have decimals. X is 5.7 approximately. X is around 5.7. And y is around 4. Was it 4? 4.1? What was it? 4.02. So it's pretty much 4 for y. Okay, so x turned out to be, again, 5.7. And y turned out to be around 4. You know the difference, right? The symbol means around, approximately. Okay, circa, approximate. I'm going to leave part B for you to practice if you need a little more practice on that. But the answers for part B, x turns out to be 11.7, approximately. And r turns out to be approximately 17.5. Okay, that's for part B in that diagram. But I'll leave that so you can practice part B if you didn't understand it for some reason. You have A now. Number 5. Hey, what's the difference between number 4 and 5? What's the difference between numbers 4 and 5?
In number 4, you're solving for a side. In number 5, you're solving for the angle.
And whenever you solve for an angle, what do you have to remember? What do you have to remember to utilize when you solve for an angle itself?
Like you have to press a second and then the negative sign.
Do you remember the calculator? Okay, it's second, right? It was called the sine what? What was the word for it? Sine, cosine, or tangent, you put a word after them though to indicate you're using sec.
Inverse.
Inverse, very good. So it's the sine inverse or the cosine inverse that allows you to solve for an unknown angle. So to solve these problems though, we have to recognize that we have to start with a ratio. What ratio is shown here? If I've got the opposite side, not the adjacent, I've got opposite and hypotenuse, sine. So for this one I've got sine, whoops, zoom in. I've got sine of theta equals opposite over adjacent, opposite over hypotenuse. And if I want to get theta by itself, I take what's called the sine inverse of both sides. Take the sine inverse of both sides of the equation. The sine inverse of the sine of theta, what's theta? It's the idea that the function cancels. So we get theta equals the sine inverse of 4/7, which is again approximately 34.8 degrees. I will leave part B for you to practice if you struggle with part A. All right, the answer for part B, though, is 20.6. The answer for part B is 20.6 degrees on my units. You're going to learn about other types of units for angles this year in your pre-calc course. You guys have missed a few already, right? Yeah. You're going to learn about other types of units. They're going to be called radians later in the year. It's not any more difficult. It's like inches versus centimeters. Radians are another type of angular unit. That's all they are. Like degrees are 360 for a circle or 180 for a semicircle. Radians are represented in terms of pi. 180 degrees is called pi radians. 360 is called 2 pi radians. You're going to learn about that this year. So for the sake of physics, we're going to have everything in degrees. Everything's going to be in degrees, not in radians. And if you look at your calculator right now, folks, hit mode. You can take out your TI, whatever you have. If you hit mode on your calculator, make sure it's set on degree mode and not on radian mode for this course. When you're in your math class, you might have to go to radian mode at times. So again, try to do this now so that you understand where it is in your calculator. Hit mode, and then make sure that degree is highlighted. If it's not, go to degree and hit enter on it so that it is on degree mode. I'm going to keep moving. I'm going to assume you're doing this as I say it, but I'm going to keep moving. So if I look at part 6 now, if I look at part 6, the only difference is part 6 just wants me to find every side and every angle. Right? Determine all the angles, all the sides. So for this problem, it's easy to get the third angle because what do 3 angles have to add up to? 180. In a triangle, 180. So I know that already this must be a value of 62 degrees. 62 and 28 gives me 90, and here's the other 90. So the third angle is easy. You don't need trig at all. Right? No trig whatsoever. It's just arithmetic. To get these other lengths, though, we're going to have to use trig. And once I get this length, what could I use if I have 2 sides? What can I use if I have 2 sides? Pythagorean theorem to get the third side. So whether you use trig twice and use trig once here to get this number, and then use trig again to get this number, that's fine. Or once you get this one, use Pythagorean theorem. It doesn't matter. You choose. The answers are as follows, though. This is, the hypotenuse is around 10.6. The base is around 9.4. And again, this is 62 degrees. Okay, that's what you'll get for answers. But again, I'm not going to redo all these problems. We just did it in numbers 4 and 5. Okay, it's the same approach you would take as numbers 4 and 5, but you have to get everything. Part B, the answers are 9.7, and you can get that very quickly with Pythagorean theorem. You could then get one of these angles using trig and using an inverse function to get the angle, and then you can get the other angle by adding up to 180. Okay, so those are your 3 values for the answer for part B. Any questions so far? Okay, move on, next page. So you guys, obviously you're in an honors course, so you'll recognize that I'll do a lot of this. I'll go over work, I'll give you credit for the work when you submit it, but it's on you to recognize whether you understand it or not. For example, again, I'm not going to be checking that this is right or wrong. So if you just turn something in that has all wrong answers, you're still going to get credit, but you're not going to benefit from that at all if you don't go back and relook at the work that you got wrong. So you need to take it upon yourself this year to make sure that you're advocating for yourself and that you're like self-assessing throughout the year. Okay? And if in doubt, you come see me about stuff that you don't understand. Number 7, the solutions are going to be, or the solution is 4, comma 2, which means x is equal to 4 and y is equal to 2. Okay, which method would you use? I asked you to use substitution here specifically because in physics you're going to use substitution a lot. You're rarely going to use elimination. You will use it eventually, but you're rarely going to use the elimination method, so that's why I indicated to use substitution method. And remember how substitution method works? You take the quantity that's equivalent to one of the variables and substitute it into the other equation for said variable. Okay, so 2x minus 6 is y, so plug that in there. Make sure you distribute the 2 to both of these terms. This is going to go in for y inside of its own parentheses. That's the one mistake that a lot of students end up making. Okay, again, when you plug in for y, it's going to be this 2x minus 6 in its own parentheses. So this would be the equation here, boxed in, that you would end up solving. Okay? That's the equation you would end up solving to get x. Once you get x equals 4, plug a 4 in there. 2 times 4 is 8. 8 minus 6 yields 2. Substitution method. A was an easy one. B was a little tougher. Not much, but a little bit tougher. So I would substitute right in again, and you would end up getting an x value of 4/5 and a v value of 2/5. Okay, 4/5 for x and 2/5 for v. And this one is set up in such a nice way, God bless you, that I would take x over 2 right here and replace v with x over 2, and then solve the resulting equation. Yeah. Any questions on part B? On part B right there. Okay, part C. Part C was a little bit trickier. Okay, a little bit trickier, and you're going to see why that is. You have multiple answers for part B, actually. There are multiple answers. So F is going to be plus or minus 1. F turns out to be positive 1 or negative 1. And N turns out to be positive 1/2 or negative 1/2. So when F is equal to 1, N is equal to positive 1/2. When F is equal to negative 1, N is equal to negative 1/2. Yeah?
How do we know when to do plus or minus or just leave it?
So let's go through this and I'll show you for this one. So we've got F equals 1 over 2n and F over 2 equals n. We could substitute this either way we like. We could take this expression for n and plug it in there, or take this whole expression for F and plug it in there. I'm going to choose to plug in from this into the first. So I'm going to take F over 2 and plug that in for n. So I'll take this quantity right here, because it's defined as n, and plug it into the first equation. And the first equation becomes this. And then the 2's cancel, and then this equation becomes f equals 1 over f. I have to multiply both sides by f. It becomes f squared equals 1. And then because I'm taking a square root, f is plus or minus 1. It's the square root that you take that is what yields the plus or minus. Okay? So again, this is the process you would take. And that would give you the answer. Not ignore, but try to section this off. Okay? That answer is in the box, but the work is all shown along the entire bottom. Questions on C? Questions on C? I'm doing on time. Number 8. Number 8 was only confusing because you're not getting an answer as a number here. You notice for number 8, your answer is not a numerical final answer. It is an algebraic answer. So it says, solve for t in equation 1. What do you get when you solve for t in equation 1? Regina?
X over v.
T equals x over v. I agree. And then substitute that into equation 2. Here's equation 2. Okay? Notice I like to use colors. You picked up on that by now to show substitutions. I recommend that for yourself as well. If you're doing several things in a problem, having color coding systems really helps to see it in your notes like a week from now, right? When it's not fresh in your mind. So consider that. Now, at this point in time, what our goal is to solve equation 2, which is this, for v. And look where v is, right? So this becomes a little bit messy to get v by itself. So let's go ahead and do that. So to get v by itself, here's what we're going to do. We're going to recognize the following. If a were a number, this would be a coefficient, and you would just divide by it. So you could divide by 1/2 a to start to get rid of it in front. You could also multiply by 2 to get rid of the 1/2, and then divide by a. Again, either way works. So if I start this problem, I could say, okay, I'll multiply by 2, and I'll divide by a at the same time. Multiply by 2 and divide by a at the same time. Well, this 1/2 cancels with this 2 by multiplying. This a cancels with this a. So I end up on the left side with 2x over a, and the right side just x over v quantity squared. So this is what I've got so far. Now again, what is my goal? My goal in these problems is to figure out, or in this problem, what the value is for v, which is down here. What do you recommend I do at this point if the value for v is down there? What are you thinking?
Take the square root of both sides.
Yeah, at first I would think the same thing, Mauro, but there's actually another way to approach this one that's probably a better route. I would normally think that. Yeah, and we'll discuss why in a moment, but I would square everything first, actually. So I make this 2x over a equal x squared over v squared. And the reasoning for this is because now one of your x's cancels out, and you're left with an x over here. If you square root both sides first, you end up with a square root with an x in it, and then you have an x over here, and it just becomes messier. It would still work, but this root is more optimal to take. Okay, it would still work, but this is more optimal. So this equation reduces to 2 over a equals x over v squared. I want to get v by itself. I'm going to multiply by v squared on both sides, making the left-hand side v squared times 2 over a equals x. Then I want to get rid of 2 over a. So to get rid of 2 over a, I'm going to multiply by a over 2. And then finally, the last step, I'm going to take the square root. Okay? So that's my final answer. X times a over 2 underneath the square root plus or minus. A lot of work to get a simple solution, or what seemingly looks simple, but it's a very powerful solution. We're going to talk about power in physics as a solution being powerful. Jeff?
At first I did the same thing Mauro said, where I would have just square rooted the whole thing. If you just left it like that, would that be correct, or do you have to?
Yeah, the problem is that you would end up having stuff with radical x and x in the answer. Is that what you had in the answer?
Yeah.
Read me your answer, Ken.
I erased it, but
What do you got? What does it become?
I erased all of that. It was x and then x in the radical.
Yeah, so you end up with an x and a radical x in the answer, which is okay, but it's more traditional to have only have that variable only appear in one spot if you can. So if you have x over radical x, it becomes radical x in the end.
what does radical mean? Sorry.
Square root.
Okay.
Square root. The symbol is called a radical. The thing underneath is called the radicand.
Oh.
So I'll use the phrase radical a lot to indicate square root.
Sorry, I just wanted to.
Yep, I know, nomenclature, I know. We were talking about that, yeah. Okay. If this problem was the one that you really struggled with, that's okay for now. For now, that's okay. But as we progress through the year, you should be able to solve a system of equations with only variables. Okay? It's all right for now if that was one struggling point, but if you really had trouble with this, I'd recommend being after school today to practice a couple more of these with me. Let's take a look at these two here. Well, actually, I might pause. Where are we at? Yeah. Let's pause on the summer packet for now. We'll start these up in another class because I don't want to spend the whole period doing this. It gets boring after a while. So let's stop for a moment. What I'm going to do is hand out the lab to start now. This is one of the simplest labs of the year. It is very rare that a lab is only front and back. This is really more of like an activity than it is a lab, to be honest. Okay? And the rationale or the reason behind this is that I want you to become accustomed to taking good measurements and to understanding your measurements, and then also taking data and being able to graph that data and understand the significance of the graph. So this is really very little physics. It's more like, again, a lot of the math you need to know for physics. So the premise of the lab is the following. It's called the circumference diameter ratio. The circumference diameter ratio. I'm going to give you a bunch of circular objects. I want you to measure the diameter, the circumference, and the height. They're going to be cylinders. I want you to measure the diameter, the circumference, and the height. I want you to measure in centimeters. I want you to read the directions because they tell you the nearest tenth of a centimeter. But read through all of them anyway, giving you a summarization. Then once you have diameter, circumference, and height for your 6 objects, which are numbered, you then are going to plot circumference versus diameter on the next page. You're going to plot your table of values. Please remember, if something says circumference versus diameter, it means circumference is on the y-axis. Diameter is on the x-axis. Is that clear? Okay, the circumference is a function of the diameter. If you have a bigger diameter, you have a bigger circumference. So it's going to be circumference versus diameter. Your diameters might only be up to like 3 centimeters. Are you going to make this 1, 2, and 3 and only use this part of the graph right here? You better not, right? So you need to think logically. You can make your increments on the x-axis go by like 0.5. And your increments to the y-axis can go by 3, 4, 7. You can make them different, but they need to be consistent on that axis. So if I do every box is worth 1 on the x-axis, that's fine. And then every box is worth 3 on the y-axis, that's fine. But I need to be consistent in my increments along each axis independently. Okay? But they don't have to be the same increment. I don't have to go 3s and 3s here. So you're going to graph that, you're going to plot it, you're going to calculate your slope, you're going to draw what's called a line of best fit. A line of best fit does not go through every data point. It is just a line of best fit. It goes not through all the points, but it goes in a certain way, this is too perfect, where it kind of aligns with all the points. But for example, if you had points here, here, all around, the line of best fit would kind of go through most of them. But you do not connect the dots. You do not connect the dots. A line of best fit is a linear function in which you will calculate the slope. Once you have your line of best fit, you're going to take 2 coordinates on the line, not necessarily your coordinates, but 2 coordinates that are on the line that maybe match up with one of your increments or where the grid lines meet to make the number nice and perfect, and then calculate the slope. And then simply answer a few questions. Very, very easy lab. Very little extra conclusion that you have to do. Okay, it's not a good example of the level of difficulty you can expect going forward. That's all I want to make clear. Okay, so don't think like, oh my gosh, physics labs are so easy. This is a very basic lab on math concepts that you really need to know. Share. Here.
I only printed the sheet last night. What can I turn it into next class?
You talking about the summer packet or the syllabus? Which one?
Summer.
You can turn the summer packet in anytime before the first test, as long as you get it done.
Alright.
So again, I'm just going to check that you did. I'm not even going to grade your stuff.
Oh.
So if you show it to me like after class, I'll mark it off my grade book as done. It's on you to understand it.
If I have an opportunity, yeah, because most
Yeah.
of the stuff I got.
Yeah.
So if I have an opportunity this class, I just finish it quickly.
Yeah, if you finish the lab first and stuff, that's fine.
Alright.
All right, so let's quickly hand out the supplies for this. So your supplies, you got 15 minutes. So in the 15 minutes, I recommend trying to get your measurements down. Okay, trying to get your measurements down. We have a lot of students in this class this year, which is awesome. I love having a lot of students, but it's tough with labs sometimes for groups. So I might have you in groups of 3 or 4 at times. I prefer not to, but for this lab, it will definitely be groups of 3 or 4. So we have 4, 8, 14, 20 that is starting. So there are 21 in the class, so it's usually going to be like 7 groups of 3 most likely for the year. Okay? So you're going to have a bunch of different circular objects, cylindrical objects, and they have numbers on them. Okay? Everybody should have numbers 1 through 6. I think I have 6 sets of them, so we might end up sharing stuff. But you should look for objects 1 through 6. Okay? So I'm going to start by putting some here. And a little bit. 1, 2, 3, 4, 5, 6, 7, 8. So let's see. Yeah. So why don't we do up to Valentina, the 3 of you. Valentina, why don't you slide over with Regina and Julie over here. You guys can do these right here. Francisco, ruler for each group, please. Next. Just give a ruler to each group. So the two of you guys, Moro, come slide up. Work with these guys up here, please. Just get this. How many did I give you guys? So more, you move these guys over here. And this is going to be 3 and 3 in the middle area. I cut all these things down, so I'm not going back. Buying this stuff. The lab, buy something for like $800. Spend $20 at PVC on people and design myself. It just shows you that like it's ridiculous. It's up to you to choose, listen, it's up to you to choose whether you're going to measure the diameter from the outer parts or the inner, but then your circumference has to also be that way though. So think about what's easier. I'm going to come around and I'm going to give every group a piece of string. You're all going to get a piece of string. Centimeters, 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 centimeters. Where are my keys? These are identical. I think this is 4. That's number 2. It's 3, 4, 5, 6. So you should have all. You should have all. Again, guys, you're measuring. You're not calculating. Careful. You are not calculating right now. You're measuring. You're measuring. Do not use 5 times diameter to find that circumference. You're only measuring right now. You are not calculating. Read your